Alright, Assalamualaikum and Salam Sejahtera. Today we will continue on the next topic, which is thermal resistant concepts. Okay, this is slide number 14. Continue from the last note lah. Lecture 3, 4 and 5 and this been combined to one PDF actually. So here we would like to introduce what is thermal resistant concept. Okay, basically what you already understand is this is Q conductions, and Q conductions is wall, means is what is the heat transfer in the wall. Q conduct wall equal to Ka T1 minus T2 or delta T and different of T over L. L is the thickness. Okay, and then this one could be rewrite as this one, T1 minus T2 over R wall. So what is R wall? R wall is equal to L over Ke. Okay, where this thing come from? Okay, actually this is equal to the electrical resistance concept. For example, here we have a T1 and T2 over here. So we have a V1 and V2 over here. So I is equal to T1 minus T2 over R, or V1 minus V2 over Re. So this is R resistant. This is also resistant. So you can derive from this these figures and get R equal to L over Ka. Same goes to the convection, or could say Newton law of cooling. This is the name of the equations, Newton law of cooling. So Q convection is equal to HAS, mean surface area, Ts minus T infinity. So Q convection is equal to Ts minus T infinity over R convections, where R convection is equal to 1 over HAS. So where this could we visualize using this figure? Solid. So we have Ts over here, temperature at the surface. We have temperature at the ambient temperature. So R is equal to 1 over HAS. So then we could get easily get this Q convection. The next one is Q radiations. Yeah, Q radiation is, this is a formula for it. So we have a Q radiation equal to epsilons alpha As Ts to the power of 4 minus T surface to the power of 4, which is also equal to H radiations As Ts minus T surface equal to Ts minus T surface over R radiations, where R radiations could be equal to 1 over H R radiate As. So this is the unit for R actually. Before this we don't have it. There, C over W or K over W. Alright. So H radiations is equal to this is been rewrite lah. We have been rewrite using the above one. So we got these things. Okay. And right, this is sort of schematic where convection and radiations happen at the same time. So Q total is equal to Q convection plus Q radiations. So the thermal concepts, H, what is R wall? R wall equal to L over Ka, R convection is equal to 1 over HAS, R radiations is equal to R convection 1 over HAS, R radiation equal to 1 over H radiation AS, where H radiation is equal to this one. Right? It's a very long formula. If the question is there, I will quote the formula there. So you don't need to remember the formula for a long formula. But this is open book, right? Open, don't know whether it's open book or not. But let's see. Okay, thermal resistant networks. Okay, basically this is the wall, and you have the infinity over there, ambient temperature 1, and you have T surface T1, we have T2 at the other side of the wall, and you have T infinity. So if you would like to draw it, this is thermal resistance network. So here is the way to draw it, right? The first one, you should draw T infinity 1, this is dot T infinity 1, and then goes to resistance number 1, which is convection. Why convection? Because this is fluid, this is wall, this is fluid, this is solid. So between these two means convection. Then it goes to R, you go to T1, then go to resistance number 2, R wall. This is wall because of the solid, okay. And then we have T2, and then we have R convection to T infinity. Okay, this one could, to find the Q, you could just do it T infinity over here, T infinity minus T infinity 1 minus T infinity 2 over R total, or here R total, T infinity 1 minus T infinity 2 over R total. R total is what? R convection 1 plus R wall plus R convection 2. Or, okay, or to find Q, you could just do this one. T infinity 1 means, where is it? Over here. Minus T1 over R1. This one, R convection 1. You already got the Q, which is equal to the other formula. T1 minus T2 over R wall. T1 minus T2 over R wall. R wall, this is convection, L over Ka. And then it's also equal to T2 minus T infinity over R convection 2, which is, this is convect, 1 over HAS. Okay, 1 over HA. Surface area, HA, this has been shorted, 1 over HA. Okay, why is H2, this one is H1? Okay, H1 and H2 is actually could be the same but could be different, and because you don't know the temperatures, or you don't know the fluid flow rate, and perhaps this is have a wind over there, so maybe the H will be bigger compared to the other one. Okay, so they name it as H1 and H2. So to find R total is equal to R convection 1 plus R wall plus R convection 2, which is equal to 1 over H1A plus L over Ka plus 1 over H2A. And the unit are Celsius over watt. Okay, let's have a look on another slide, which is, this is multiple plane wall. For this we have only one plane, so this is we have multiple plane. So this is we have wall 1 and wall 2. This is different material. Why? This is K1 and K2. If you see the gradient is a bit sloped compared to this, right? And because of that, we need to first thing, when we want to do this calculation using thermal resistance network, this actually when we want to calculate something that sandwich like this, the best thing is to do thermal resistance network. Okay, so just draw this thermal resistance network. This is, we have it, T infinity 1 there over there, then we got, this is resistance number 1, T1 over there, we got resistance number 2, and we have T2 at the middle one, and then we got resistance number 3, and then T3 and resistance number 4, or T infinity 4, T infinity 2, the last one. Okay, then we recognize what is this resistance. This resistance is either is convection, radiation, or conduction. So perhaps you could see this is fluids, we have H over here, this is ambient, then this is convection. So our convection 1 is equal to 1 over H1A. Then we have wall, and our wall, this is, of course this is solids, we have K over here, so our wall is equal to 1L1 over K1A. L1, why? perhaps this length is not equal to the other line, so they give L1. Don't just write L because this is L1. And we have another one is R wall 2 L2 over K2E, and we have the last one is R convection, which is equal to 1 over H2E. Okay, in total Q is equal to T infinity 1 minus T infinity 2 over R total. So just calculate R total, R convection 1 plus R convection 2 plus R convection R2 plus R wall 2 plus R convection 2. We got everything, and we got R total, plug in there, we got Q. Okay, let's see on another one. Here, okay, here just to show that heat transfer rate Q is constant, is constant. So to find the Q and to find T1, this the other way lah, the other way of besides calculate the Q, we could ask you to calculate T1, calculate T2, calculate T3. So you could use this formula, Q1, because Q is the same. Q over here, heat transfer rate over here is equal to heat transfer rate at the middle is equal to heat transfer rate of the wall 2 is equal to heat transfer rate of this Q. Let's say that Q over here. So this will be Q is constant towards this one. So to find T1 is equal to Q over T infinity 1 minus T1 over R convection 1. So to rewrite this one, everything plug over there. Left T1, you got T1. Okay. As been said before is, okay, when you have such a wall, this is wall 1, you have wall 2, so whatever you have Q over here, this is Q1, this is dot Q1 perhaps, and this is Q2, Q number 2, this is Q number 3, and this is Q number 4. This just assume. So actually Q1 is equal to Q2 is equal to Q3 is equal to Q4. So everything is equal to Q dot. That's why it's been said that Q is constant. So if you need to calculate whatever over here, actually you need to know this is perhaps this is the T ambient. T ambient. So perhaps for example you have T ambient and T ambient 1. This is you have T ambient number 2. So this is this is at surface temperature T1. Just name it T2. You name it over there T3. You could name it whatever you want to name. So Q1 is equal to T infinity 1 minus T2. This is directly minus T2. Minus T2 over what? Over R total. Okay, R total of what? R total of T1 minus T2 over R total of this R. So you have over here R1. So this is you have R1, you have R2, you have R3, you have R4. So total of what? R1 plus R2, because of you are using this. Because of you are using this one. You are using up to this. From here up there. So I'm using this one. So this is which is equal to T infinity 1 minus T2 over. The handwriting is a bit sliding. Alright. So this one is R1. R1 is 1 over H1 E1 plus L over KA. E1 also K1. Okay, so you have this is L1, this is over here, so R2 is over here, and this is L1, length is L1, perhaps, I don't know, this is length L2, name it, you just name it. So plus make sure you write draw it nicely when you want to answer whatever question I give you, especially in the final, so I could read it well and give you the best mark that you could get. Okay, so this is the formula to find it. So if Q is already been given, so just rewrite this everything, put Q, then you rewrite, leave it T, bring everything over there, so you could have it T2. What is T2? That will be your just there. Okay, next one, exercise. Okay, please complete this exercise. This is using thermal resistance network. You need to draw it. And submit it. I will give you times on you to complete it, but make sure you need to complete it. Okay, thank you very much. So here you have several exercises. Not much. Yeah, up to that. 1, 2, 3, 4, 5, 6. Only 6 questions. Don't worry, why you need to answer this. I gave you why. Heat transfer is one of the killing subject when I studied before. So the way you want to solve to settle this killing subject is by doing a lot of exercise. So perhaps by doing exercise we will understand it well, and perhaps one of the question will be out for the midterm or final. Okay, thank you. Assalamualaikum dan salam sejahtera.